Okay, so 3B. 3B is a really good example of the necessity of reading very slow and very careful and writing as you go. For example, let's jump over here. Okay, it says the rate of fuel consumption. The rate of fuel consumption. So right there I need to make sense of what that's saying, and I need to try and change it to symbols instead of words. That'll make the problem easier. So rate of fuel consumption. So in this problem, what symbol represents rate of fuel consumption? Capital R. So as I'm kind of reading the problem, that's what I'm going to write down. I'm going to say, and I know I'm kind of going extra slow here, but just to emphasize the importance of going slow. So rate of fuel consumption, that's R of T. So R of T is increasing. So R of T is going up fastest. Okay, that's a really short statement, but it tells me a very key idea. And it's back to Danica's chart. So I have amount, and I have rate. Well, R of T is a rate. It's rate of fuel consumption, measured in gallons per minute. That means the amount, even though they don't give a symbol for it, would be A, we'll say, and that would have to be measured in gallons. It's like how much fuel there is. And then, so this is how much fuel there is. R of T is how fast that fuel gets consumed. There. Okay, so this R of T is going up fastest. Well, it's the rate of the rate. So this would be R prime. The rate of the rate is what tells me how fast the rate itself goes up. Just like this rate tells me how fast the fuel is consumed. See what I'm saying? Okay. So they're saying that R prime is greatest. At time equal 45. Because that's where R of T is going up fastest. And R prime tells me how fast R of T changes. So when R of T is changing fastest, that's where R prime is greatest. Does that make sense?
Somewhat.
Let's try a numeric example. It's usually easier for our brains to understand the relationship between these two than it is for our brains to understand the relationship between these two. It's just a little bit harder. But the relationship between amount and rate is actually mathematically identical to this relationship. So once you feel good about this one, then it's not too hard to jump to that one. Okay? So here's the example. This R of T tells me how fast the amount will change. Think of it this way. You have this plane. The plane has a fuel tank. The tank has some amount of fuel in the tank. R of T tells me how fast this fuel disappears. So like right here, the fuel is disappearing at 55 gallons per minute. It's being consumed 55 gallons every minute. So R of T is telling me how fast A of T changes. So in this table, we don't have enough data shown, but in this table, we would say, oh, at this time, where R of T is 70, that's when A of T is changing most rapidly. It would be when A of T is going down the fastest. because this tells me how fast this changes. That would mean that this would have its highest value at that time because that's when this is changing most rapidly. That makes sense? So they're doing the same thing, but they're doing it between these two. They're saying, okay, at time equal 45, that's the moment when this rate is going up fastest. Well, this tells me how fast this will change. So, therefore, if, that's a lot of words, if this is going up fastest at time equal 5, that means R prime has its greatest value at time equal 45.
I didn't get that.
Okay. So if we were looking at a picture of R prime, we'd say, oh, R prime must have a peak at time equal 45. This has got to be R prime, because R prime is the rate at which R changes. R is changing fastest at this time, therefore the value of R prime has got to be highest at that time, because this value tells me how fast this changes. So if R prime has a peak at time equal 45, R double prime is the slope of R prime. So the slope of R prime right there the slope of R prime right there has to be 0. So the answer to this question is, at time equal 45, R double prime of 45 has a value of 0, like that. Yeah. Explaining that to me is a little bit tough on the brain. But here's what I finally wrote in green, which I felt like was the most concise way to say it. We know that R is going up fastest at this time. That means R prime has to be greatest at that same time. It's like R is rising rapidly like that, but R prime is the slope of R, how fast R changes. So where R is going up fastest, that means that's the slope of R is going to be steepest. That means the value of R prime is going to be highest. And that means the value of R double prime, since R double prime is the slope of R prime, has got to be 0 at that spot.
Could you also say that